In this and coming sections, I'll review neuroscientific evidence against the claim that we have free will, and then discuss why I think this evidence is in fact not strong or even valid evidence against free will in the human brain. There are two main bodies of evidence often taken as proof that we lack free will. One stems from the Libet experiments and the other from the Wegener experiments. Here, I'll discuss the Libet experiments, and then in the next section, I'll discuss why Libet's findings really have very little bearing on the issue of free will. And after that, I'll do the same with the Wegener experiments. In discussions of volition and will, it's useful to distinguish distal acts of willing, for example, willing to take part in an experiment and all that that entails, from proximal acts of willing, for example, willing to move one's finger during a particular trial of an experiment. Distal willing involves coming up with a plan that plays out over minutes, hours, days, or even years.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
Proximal willing generally involves choosing to do this or that in the immediate future, perhaps some seconds from now. Experiments in the tradition of Libet test the assumption that acts of proximal conscious willing play a causal role on each trial where a movement is made. What Libet and his followers have studied is whether the proximal will to make a movement at a particular time plays a causal role in the sequence of events that culminate in a willed motor act. Despite Libet's strong claims about the causal inefficacy of consciousness, none of his experiments tested the possible causal efficacy of distal willing, which could be causal of subsequent motor acts even if proximal acts of willing are not. Thus, Libet's data cannot be used to support or rule out any possible role for free will in the domain of distal willing, that is, intending to perform a future action or complex series of actions. As I've mentioned earlier in this course, I think deliberation and imagination are where the action is in free will, not in picking between meaningless options arbitrarily, like moving a finger or not, or moving the left hand or the right. Libet's experiment focuses on the latter kinds of picking choices, not on the consequential choices we deliberate about when we plan for the distal future. Now that it's clear that we're only talking about proximal acts of willing, we can get into the details of the Libet experiment. Here's a picture of me wearing an electroencephalography cap of electrodes. We generally abbreviate electroencephalography using the letters EEG. EEG measures brain waves at the scalp. The strength of electrical signals are highly attenuated after passing through the skull and skin at the scalp, but if you do enough averaging of trials, the noise gets averaged away and you can get a pretty good average waveform. This average waveform is called an event-related potential. This requires averaging relative to some common time point, which is the event in question, such as the time that a hand movement begins. So, in 1983, Benjamin Libet and colleagues reported that an event-related potential called the readiness potential precedes a volitional hand movement. Subjects were told to move their hand whenever they freely chose to do so. They also watched a rapidly rotating clock and were told to report the position of the clock when they first had an awareness of wanting to move. Here's a simple drawing that sums up the basic results. Let's call the time of the hand movement time m. It's the point in time relative to which Libet did his event-related averaging. W is the average time at which people reported feeling an urge or intent to move. As you can see, the beginning of the readiness potential precedes time W by several hundred milliseconds. Because it precedes the conscious experience of wanting or intending to move, it's presumed to reflect unconscious processing that precedes becoming conscious of wanting or intending to move. The readiness potential is a slowly rising change in potential or voltage that is strongest right about here, right above an area known as the supplementary motor area that is thought to be involved in the planning of motoric movements. Well, it's not surprising that measurable brain activity precedes a volitional action because brain activity presumably causes that action, so has to precede it. What was surprising to many people was that the beginning of the readiness potential also precedes the conscious awareness of willing a movement to occur. Over the last few decades, the readiness potential has proven to be one of the most controversial topics in neuroscience and philosophy due to its perceived relevance in elucidating the role of conscious will for action. Put succinctly, Libet's key innovation was to investigate the temporal relationship between the onset of the readiness potential and time W, the reported time at which subjects' subjective experience of wanting or intending to act began. His data revealed that, on average, the readiness potential begins several hundred milliseconds before the time of conscious awareness of feeling an act of willing at time W. This called into question the ability of the conscious choice to influence the timing of the movement. Basically, if something pre-conscious and unconscious precedes our conscious willing by several hundred milliseconds, maybe that unconscious process is the actual cause of our volitional movement. Maybe the conscious willing itself only seems to cause our motor act. Since we do not seem to have control over our unconscious processes and can't even report what they are, if everything is decided unconsciously, there's no room for our consciousness to be in control of our actions or, presumably, to have chosen otherwise than those unconscious processes already decided for us. To make this worry clear, here's an analogy. When I'm about to sneeze, I feel a tingle in my nose that precedes my sneezing by a fraction of a second. But just because something precedes my sneezing does not mean that it causes me to sneeze, just as a rooster crowing before dawn does not mean that the rooster's crowing causes the sun to rise. When it comes to my sneezing, there are other things going on before I become aware of that tingling sensation in my nose that are the actual causes of my sneezing. There are unconscious processes that detect dust or something in my airways that needs to be ejected, and these unconscious processes both trigger my later conscious awareness of being about to sneeze, and they trigger the actual sneeze that happens a bit later still. In this sense, the feeling of tingling in my nose is epiphenomenal. It's not the actual cause of my sneezing. It's just a conscious feeling that precedes and accompanies my sneezing, which is really started unconsciously before I become aware of that conscious feeling of nose tingling. On this analogy, the feeling of being about to sneeze would be analogous to the feeling of willing to move my hand in the Libet paradigm. And the unconscious processes that make me sneeze would be analogous to those unconscious processes associated with the start of the readiness potential. The analogy breaks down in that sneezes are not really volitional, whereas the hand movements that Libet investigated were volitional. But really, if Libet is right, it's questionable whether there are any truly volitional processes at all. Maybe mental causation all boils down to unconscious causes that lie beyond our conscious control. Maybe, if Libet's right, all of our actions, seemingly volitional or otherwise, might be variations on sneezing. We might feel that we can consciously control them, but in fact, that feeling would be epiphenomenal and illusory. To make matters more complicated, there's another event-related potential called the lateralized readiness potential, which is measured above motor output areas right about here. When I move my right hand, the contralateral or left side typically shows more activity than the ipsilateral or right side, and vice versa when I move my left hand. The difference between voltage here and here is called the lateralized readiness potential, which also precedes the time of first conscious awareness of wanting to move. That is, it begins about 600 to 800 milliseconds before time m, namely the time of moving my hand, and also precedes time w, which precedes time m by 200 to 400 milliseconds. So we actually have two event-related potentials that begin to be detectable before we consciously become aware of intending or wanting to move. However, it remains unclear how either the readiness potential or the lateralized readiness potential is causally related to either conscious willing or to movement, or even whether it's really related to them at all. In the next section, I'll present evidence that the Libet experiment cannot be used to support the claim that we have no free will, and can also not be used to support the claim that consciousness is not causal of any of our actions.